Thank you for having us again here. I was actually down the hall 2 NFDs ago. Spent a lot of time talking about optics and those sort of things, and so I'm going to try and not do that this time. I'm going to try and because I still remember what you asked, Greg, which was I'm more interested in what the heck does the controller do. So I'm going to rehash it a little bit because obviously we have a sort of a split audience. I'm not going to go back to the beginning of Plexxi because hopefully that's sort of well known. But I'm going to backtrack a little bit to what Matt presented at the last NFD, because that sort of came in between some things at the beginning, and then of course Derek with the DSE at the end of it, about Switch2, about multiple degrees, about how we scale things, how we intend to sort of grow, and what the flexibility of that gives us. So I'm going to backtrack just a little bit to what Matt presented, talk a little bit about our second switching platform, but then focus mostly on what does it enable to do, what can we do with that. And in the second part, talk a little bit about, we have a bunch of customers, paying customers, which is always a good thing. Talk a little bit about what do they do, right? Because we've talked about this as technology and what can you do. Trying to sort of go a little bit more practical, what are these customers doing with it? I picked 3 very different customers in terms of what they intend to do with it, and sort of explain a little bit about what is it they like about the Plexxi solution? What is it that they use about the Plexxi solution? Just sort of walk through a little bit what captured those customers in our overall story. So I'm going to start with this picture, and so this picture was in the previous presentation as well, but I wanted to sort of mention this one more time because I know Matt ran through this fairly quickly. This is our second generation switch. It looks very similar to our first generation switch, except that it's a little higher. This is a 2U switch. It's a Trident 2 base switch, like many other switches that you see on a day-to-day basis. It has ports on the front, QSFPs, SFPs. What's different about this switch is, again, similar to what's different about our first switch, is our way of creating a fabric. Right? We create a fabric not by taking front panel ports, 10 gig, 40 gig, connecting them together into all the switches. Right? We have created what we call the light rail port, which essentially takes a large chunk of the bandwidth from the Trident that sits in there, and we use that to create an interconnect between our switches. Most of you should be aware we don't create a hierarchical switching structure. For us, it is cabled in a ring kind of fashion, but ultimately what that means is we build a mesh of 10 gig physical connections between our switches. One thing that you'll see if you count it, it's hard to see on this picture, right? But there's essentially 16 QSFP ports on here, and then there's another 12 SFP plus, and then these are some debug ports. If you add the capacity of all those ports up, that is far more than what a Trident 2 supports. And because each one of these light rail ports, similar to our previous switch, will support 12 10 giggies in one direction, 12 10 giggies in the other direction. So there's 480 gig of capacity in our interconnect, and then there is the rest that's out here in the front. And there's more ports here than we have bandwidth for, and I'll explain that in a minute. Those are we call them flex ports. And when we get to our use cases, you'll see that there is a very unique use of these flex ports, these ports that are actually not assigned to anything, that can be dynamically assigned, and how some of our customers use that to create their solution. So besides that, it's a fairly regular Trident 2 base switch. We've beefed up the CPU a little bit. It's got an Intel i5 quad core in there compared to most other switches that have a Freescale or so kind of switch. But other than that, it's a switch. It's a 10 gig switch. For us, yes, we do some things in here, but other than that, it's an enabler of our ultimate solution. If you look inside at a very high level, this is what the architecture of the switch looks like. Obviously, we have the core of all packet forwarding. Again, Mike mentioned this is about workload. Trident 2 is in here. There's no secret there. It has 48 of its ports that are connected to front panel ports. So 48 10 giggies are connected to the front, either as 40 giggies, 4x10s, etc. But what we've done different is we've taken half of the capacity of the Trident 2, and instead of also bringing that to front panel ports, we've connected that to an optical cross-connect. So we have a cross-connect inside of the system that we can control all of the inputs and outputs, and we can connect them together. In the normal way, when you take the box and you boot it up, these 48 10 gig E's here are mapped onto the light rail ports. 12 go here, 12 go there, 12 go there, and 12 go there. Right? That creates our light rail, that creates our 12 by 10 connectivity out of each one of the ports. Matt mentioned it last time, and I don't have it in here specifically, right? Our traditional solution has WDM, CWDM as a mechanism to transport each one of those 12 10 gig E's. So there's 12 10 gig E's going out over a few fibers. But we also have a solution that uses regular 1310 optics for these light rails, uses slightly different cables, same connector, slightly different cables, 1310 optics, a little bit cheaper, a little bit lesser reach, right? But ultimately it drives the price of the overall solution down. I mentioned these flex ports, right? So we have these additional ports, these additional SFP cages and QSFP cages that sit in the front of the switch. And as you can see, they're actually not connected directly to the Trident 2. They're connected to our cross connect. And what this allows us, this optical cross connect allows us to create any connectivity between these ports, and those ports. So we can actually change the way things are configured. The only thing that's fixed is these 48 10 gig E equivalents here at the bottom, the access ports. Those are the ones that are fixed. Everything else we can change. We can decide to take connectivity or bandwidth away from our light rail ports and spit them out the front. We can decide to take connectivity that comes in one of these ports, switch it across our optical cross connect and out a light rail port without ever touching the Trident 2. So we can actually take an optical path in a port through the cross connect out to our fabric, and on another switch somewhere in the fabric, come in through here, cross connect, out a flex port, have an end-to-end optical connection without ever touching a packet switch. That's part of the flexibility.
That's a SFP cage. I mean, the back of SFP is electrical.
Sure, but you know the SFP Plus, you plug in whichever flavor SFP Plus you can get, right? And it's a somewhere between a 1 and 11 gig, because that's what the electrical interface allows you to do, signal. But what it is within that doesn't really matter. The cross connect is a truly optical cross connect. Obviously, there is a limit in terms of you can't just spit any optical signal across that. Anything that comes in on an SFP Plus, we can transport across here, however framed it is, whether it's Ethernet, whether it's fiber channel, InfiniBand, as long as it fits within that range of what an SFP Plus timer can do, we will transport it without looking at it ever as an Ethernet frame.
But you're turning it back into optical.
Yes.
In the back of the SFP.
Yes. I mean it's optical. Obviously, there's electrical in the back end of the SFP. Optical out, come back out, gotcha. And etc. The other way goes around. And I'll show you in one of the examples that we have of a customer use case of how they actually use some of this. Now, with that second generation switch, where we've created sort of an additional set of fabric ports and an additional set of light rail ports, we can actually create multi-degree topologies. Right? I think all of you should be aware that we essentially connect our switches together in a ring topology. They're cabled in a ring topology, but on top of that ring, we build point-to-point 10 gig E mesh of connectivity between the switches. Now, in our first switch, we only had one set of connectors, right? One went to a switch on our left, one went to a switch on our right, so we can create a single ring and that's it. With this second switch, we actually have 4, so we can now create multiple dimensions. We can go left and right, but also north and south. Now, initially, the first thing that we're going to do, because obviously this requires some software support that comes along with that, but with the release of this software, which is next week actually, and the hardware that comes along with it, first thing we can do is, if this is a ring, oops, let me not trip, a ring of switch 1s, which are the little boxes, adding a few of these switch 2 platforms in the middle, 1s and 2s are backward compatible, they talk to each other. You can actually create extra capacity, right, where you have that initial light rail fabric connection that goes across and creates an internal ring. You can create another ring across that between all of the switch 2s. And what that does is creates another 120 in each direction gig worth of capacity between each of these switch 2s. Now ultimately it's like, okay, that's just extra capacity. But the foundation of what we do is mapping traffic to a topology. And each time we add one of these links, we add 120 gigs or 12 times 10 capacity between this switch, because some of it is passed through between all these switches. So we've created another 24 paths for each one of these switches to the other switches that follow in that same outer ring. More paths, more diversity, more opportunities for us to place traffic onto. You can take that even one step further, and you can create multiple of these concentric rings. And again, right, the ring format is only there as a mechanism of cabling. Connectivity is not in the ring. Connectivity is a mesh of point-to-point connections between the switches. You can keep repeating this, right? So now we have this outside ring where, right, you have these multi-degree switches on the outside that have additional capacity between them, additional paths between them. You can do the same thing with another set of multi-degree switches in between and create another set of paths between them. And you can essentially keep repeating this over and over and over again. What it does is create more and more paths from anywhere in the network to anywhere else for our controller to then select, how do I get from one place to the other? Because that's ultimately the foundation of what we do, right? Our foundation is, like Mike said, we're a math company. And we're masquerading as a software company, masquerading as a company that sells switches. Ultimately, the key of what we do is math. How do we take traffic needs from applications and map it onto a network that has as many diverse paths from anywhere to anywhere as we can possibly create? So that's the foundation of this. Now, if you take that one step further, let me build this out. Oops. If you, I'm sorry, guys. There we go. If you take this one step further, and again, this requires a little bit of software for us, so I'm talking a little bit in the future here, but that same switch, you can now create sort of, Manhattan grid style networks. I know we've talked about that before, but with this switch, we actually, enable the ability to go and do that. You can actually have switches that have connectivity to switches in that direction, connectivity that have switches to other switches in that direction, and you can essentially hop from anywhere to anywhere with. The largest we've ever done on paper was a 65,000 port network, and there was a maximum of 5 hops between anywhere and anywhere. Maximum, right? In many cases it's 1 if you stay within the same place, or it's 2 or 3, but it was a maximum of 5 hops.
It's 5 hops through silicon?
5 hops through silicon. Tried into like 480, 500 nanoseconds, that kind of speed. Right, so you're talking 2.5 microseconds to get to anywhere in 65,000 ports. Now that was as large as we build it on a piece of paper, and it's actually kind of hard to draw a multi-dimensional, because this becomes multi-dimensional, because now you can start take one of these, and I'm actually going to start connecting islands of those together in a third dimension. This can scale to absolute ridiculous amounts, to the point that as you can see here, right, the only way you can actually draw this is just by drawing a couple lines and examples of this is what it would look like, but it's really hard to actually draw this out. For us, the biggest that we've ever drawn, that's sort of the 5 hops that we talked about, was an 11 switch by 11 switch by 11. So it was a 3-dimensional 11 switch matrix, right, a cube almost. So that ends up being 1,000 switches or something like that. Like 1,200 switches, 48 access ports. That's how I got to that 60,000 number. So, now, are there a lot of people that build networks like that? Today, no. There's very few that have networks of that size or want to build them that way. Right? But the ability to create a network like this, and it doesn't have to be flat, right? I mean, obviously today, and we've talked about, one of the nice things that you can do with the Plexxi network is create a sort of a seamless layer 2 flat network. VLANs sort of span everywhere. We realized very well, right, this is not a place where you want to stretch VLANs from anywhere to anywhere. But the nice thing is you can. And it's all under a single management, single control, and the paths are fully controlled by a controller. Right, so you can create the physical connectivity, but then ultimately it's a controller that walks through the math to figure out, how do I actually need to go from one place to the other? Now, the other thing that this switch enables for us, let me just build this out entirely. And we see this, and I come back to this a little bit later, because there's one customer that is essentially doing just this. and I wrote this in our blog last week. I mean, obviously, because we have some of these optical capabilities, there have been quite a few companies that have asked, well, can I use this to connect data centers together, right? Can I use this to connect data centers across a campus, across a metro, or even beyond that? And the answer is yes. I mean, if you look at the typical way you would connect data centers together, you would have data center on the bottom, data center on the top. You have some transport in the middle, right? Whether that's an MPLS network, whether that's a Metro Ethernet network, whether that's a lease line network, it doesn't really matter what that is, but you have some sort of connectivity between the data centers, but you have typically very well expressed borders between those data centers. You have sort of an edge of one data center and the beginning of another. What the Plexxi solution allows you to do is actually take that, and instead of having sort of a point-to-point, routed or otherwise switched network in between, simply extend the Plexxi network across a wide area. I mean, internally, if you take the box as it is today, it comes with 10-kilometer optics, so it already gives you at least campus reach, and in many cases will give you sort of metro reach as well. But if you take into consideration what I explained with those flex ports, we can take those fabric links, right? These things that we make our fabric with, how we take our switches together. If you take one of those links and redirect it out of the front port and stick in DWDM transceivers, right, all of a sudden I can use 80-kilometer optics or whatever else I can get my hands on to create my Plexxi fabric. So I can actually start attaching my switches together, not just with the regular light rail cables that I have, but I can actually program the switch to take fabric capacity away from those light rail ports, bring them to one of these flex ports, and plug in whatever optics I can get my hands on. And whether that's native DWDM, 70, 80 kilometers, or whether that's a wave that is then transported across some third-party transport, an alien wave, right? Somebody gives you a wave, you match that, it simply gets transported one side of the ocean from the other side of the ocean if you want. Or on dark fiber, right? That's one of these nice things about these flex ports and flexibility. We can actually take, because these fabric links for us have a special meaning, right? We use those to connect switches together. They're recognized as switches talking to other switches, but because we can redirect them to other places, without you having to configure a single thing, we can redirect them, bring them across some long-term transport, and the fabric gets created just like it was if this was inside of a single data center. The switches know no different. As long as they see traffic on a fabric link, they don't actually care where that fabric link is coming from, whether it's coming in on a light rail port or whether it comes in on one of these flex ports. It's a fabric port, it's treated as a fabric link, it creates a fabric. And in that case, this is actually managed as a single entity. I'll come back to that because there's actually one customer, which is a fairly large layer 2 transport customer that uses exactly this, and I'll give you an idea of what kind of capacity these guys are looking at between the data centers for transport. Good thing about this, and this is where we're getting a lot of interest, and I'm sort of stepping forward to the types of customers that we're seeing that sort of are attracted to our solution, is it actually removes quite a bit of optical components from the entire solution. You can go fairly straightforward into either existing optical gear or simply if you have dark fibers in a MAN or a campus kind of area, plug that straight in.
Run straight into a commodity electrical platform until it works.
Absolutely correct. Absolutely correct. Absolutely correct.
Assuming you didn't want to just go straight out of the back of the Plexxi.
Correct. Correct. So I'll get back to this. I'll actually have an example. There's two more detailed pictures of one customer that actually does that. This one is actually sort of a good representation of that customer. I'll explain a little bit more later, but if you sort of zoom in on that right picture, one way that could look like is I have sort of what looks like a ring over here and it looks like a ring over there. And normally you would have sort of these guys talking to each other amongst themselves and those four over there amongst themselves. If I want to turn this into one ring, I need to take the fabric links here that make this guy talk to this guy, and I need to take these fabric links and move them over in that direction. I need to do the same thing here. Right, the fabric links here that make this switch talk to this one, I need to sort of move them in that direction. I need to sort of create that logical ring kind of structure. So what we're doing is, right, normally these are 12 10 gig E's that come out of a light rail port out this way. With our flex ports, our optical cross connect, we essentially push them out. That's why we have these extra ports on the front. out the flex ports, 12 by 10 gig E's, and you can ignore the terminology in here, but these all have slightly different meanings. We have one wave that has a control channel that talks between the switches, but essentially 12 different waves that come out in whatever SFPs you've plugged into, go into either a passive mux across a dark fiber, a passive mux onto an alien wave infrastructure that simply carries whatever waves you pop out, comes in on the other side, comes in one of those flex ports, and we map it back to a fabric port. And as far as this guy is concerned, right, he is talking a normal Plexxi fabric link to the guy over there, and we've created essentially one big fabric network. We'll do the same up top.
Does it have to be to the guy over there, or could he be optically passing through to the rest of that room?
So, very good question, because the links that actually arrive in here, you can decide, because again, we have that optical cross-connect, we can decide to terminate them on the Trident 2 here, so terminate it as an Ethernet connection here, or pass them along, stick them onto our light rail, and bring a couple of 10 gig E's over here, a couple of 10 gig E's over there, a couple of 10 gig E's over there. The customer I'll talk about later does exactly that. Right, so they'll actually take more than 12, but for this case, they'll take these 12, they terminate 6 of them here, and then bring 2, 2, and 2, optically passing them through our light rail. So in that case, they've essentially created a 10 gig connection from here all the way to this switch over here, right, without ever having to touch anything more on transport than this. Very flexible. And the nice thing is they can change it, right? It's programmably changeable.
The control base and bypass business, that's not reserved.
So the only thing that's special in here is control, right? Control is a channel that we use where the switches actually talk amongst themselves. So each of the switches, right, they're regular learning switches, so they learn MAC addresses and all those things. They communicate what they learn. Right, so if a switch learns a MAC address here, he'll tell everybody else that he's learned a MAC address. Same for ARP information. They use the control channel to talk to each other, who's there, who's not. Right, so there's some basic hello protocol. So there's some basic communication that happens between the switches. So the control channel is the only thing that's special and is one that sort of hops, between all the switches. All the other ones are essentially waves that you can take wherever you want. They are point-to-point 10 gig Ethernet connections. We call them slightly different names. These are more internal names than anything else, but ultimately they're simply 10 gig connections that you can terminate wherever you want. And it's all programmable. Right? This is not, you got to go in and plug something in. The moment you've created this connection here, where those 12 land is completely programmable right from the outside.
Does routing occur at the first switch that receives the Ethernet?
Today, absolutely. Today in our solution, the first switch, so in today's solution, and again, that's something that we know we will need to get to an abstraction once it starts to grow. Today, every single switch will route for every single VLAN. Right? So if a packet needs to be routed, whichever switch it lands on first will route and is switched from there on in. Realizing that once you get to hundreds of switches, you need to create some abstraction. This is where there's multiple degrees get in. We actually can create abstractions between those degrees and actually do routing, not just as a flat network, because at some point that won't scale, but actually create sort of routing abstractions among that.
So now that we're talking about scale that's transcontinental or transoceanic, even potentially between data centers and this interconnect, that breaks the latency factor a little bit of what we do in data centers. Are there any implications of increased latency for the Plexxi platform at its core?
So let me try to answer the question slightly different. Control is aware, or let me rephrase it. You can tell control that these links, or controller which essentially maps the traffic onto things, you can tell it that these links are slightly different, either slightly different in terms of bandwidth or slightly different in terms of latency. So you can describe a slightly different behavior onto these links. So when it does its magic of fitting, which I'm getting to next, it can actually take into account that if you want a low latency connection, I'm going to try and avoid those as much as I can, because I know you're going to incur 10 or order of magnitude higher latency here than you would within here.
Okay.
All right, so let me, that's about as much hardware as I'm going to talk about in optics I'm going to talk about. But it sort of lays the foundation for, fundamentally what we do. And this goes back to Greg's first question 2 NFDs ago, which was something that we probably didn't spend enough time on then, but is ultimately the math part, the foundation of what we do. You may have seen this picture or some variation thereof. This is our overall architecture. There's a lot on here, but I just want to sort of highlight the piece that I want to talk about. Obviously, you talked about hardware, and I've talked about hardware enough. I'm not going to talk about it anymore. The fine gentlemen over here are going to talk about this top part, DSC and an integration with Open Daylight and everything else, similar to the last NFD where they talked about DSC integration with Puppet and Chef and those sort of things.
That DCI feature really interests me because being able to turn a switch fabric up between data centers and have a unified Ethernet fabric extended between two, combined with your controller platform, which we'll see next, that's really fascinating to me.
Good. I'm glad you're saying that.
Yeah.
So I'll come back as there's actually two customers that have slight variations of just that. And if we look at all of our customers that we have today, customers that are running this either in production or sort of an extended trial, probably about half of them are actually running some flavor of DCI. Not everybody's running it as a direct server-to-server data center across everything. Some are using it as a core between data center or an aggregation between data centers and have regular top of racks in between it.
This case I'm thinking of is companies like, say, large-scale, mid-sized cloud providers who've used a facility to do the first phase of growth and now need to make another one, and because there's no physical space left in the building that they're at, and they need to present one cloud resource but in multiple geographic locations that are close by, like central London, for example.
Correct.
Right? And so I need to have one single Ethernet fabric for the automation capability, but they're separated by 5 miles.
So there's one customer that is probably not represented on here. It's more of an enterprise customer. Let me talk about that when I get there as an example, because they're doing that in a slightly different context, but for very similar reasons. So I talked about the hardware. So what I want to talk about is sort of this portion here. We haven't talked about that a lot in previous sessions. Is what does our controller do, right? And the controller does provisioning, configuration, right? You got some debugging, you got nice pictures and all those sort of things. I'm not going to talk about that. It's more around how do we actually get from creating a physical network that has all these 10 gig connections running between the switches, and then we have these requirements that come in through affinities and everything else. How do we glue these things together? Now, I tried to sort of do this in the most simplest terms, because ultimately, part of it is that simple, even though the little whiteboard scribbles here are the complicated part.